Random variables. This lesson we'll talk about what a random variable is and how to use it to solve problems. A random variable uses numbers to describe the possible outcomes which could result from a random experiment. Random variables are often represented by capital letter X. So let's talk about this. If we flip a coin 3 times, the random variable is not going to be heads or tails. What it is something like number of tails or heads, right? So if I flip a coin, my random variable X could be, I could get tails 3 times, I could get it 2 times, I could get it 1 time, or I could get it 0 times. It could be all heads. That's what X represents, the number of times you could get a certain value. So it's not going to be heads or tails, it's going to be the number of times you get a certain thing. Now we can do a random variable that's discrete or continuous. If you remember, discrete means a possible set of values that have to be concrete. There's like, I always say like shoe sizes, they come in 3, 3.5, 4. They don't come in like 3.25. So same thing here. The number of defective, so for a couple examples, the number of defective light bulbs in a purchase order of 50, so you buy 50 light bulbs, you could get some of them are defective. You're not going to get half a defective light bulb. You can get 1 defective light bulb, 2 defective light bulbs. You're not going to get 3.2 defective light bulbs. It has to be a certain number. So something, if it's something you could count, then it's discrete. You can also get a continuous random variable. So like this, I always say like height or like your actual size of your feet. It could be any number, right? Like the winning time of a race could be anything. So some examples: height of men, right? There's no, you don't have to be 5'10", 5'11", it could be anything between. The amount of water in a tank or in a glass, there's no like set amount. It doesn't skip. It could be any value in between. Best way to think of continuous is as a measurement. So let's do an example. So a supermarket has 3 checkouts, A, B, and C. The government inspector checks the weighing scales for accuracy at each checkout. The random variable X is the number of accurate weighing scales at the supermarket. So again, notice how my random variable X is a number. It's a number of accurate weighing scales. So none of them are correct. It's not correct or incorrect. It's, oh, how many of them are correct? This is how possible outcomes correspond to X values. So for A, we have 3 supermarkets, 3 checkouts, and we want to know how many are correct. So I want to list all the possible values. Well, they could all work, right? Or maybe only A works and these 2 don't work. Or switch it up. A doesn't work, B works, and then well, C works. You can also do the pairwise. A and B work, but C doesn't. What if A doesn't, but B and C do? And then you could do, what if B doesn't work, and A and C do? And there's one last one. What if they all don't work? Those are all the possibilities, right? They all work. 1 of each works. 2 of a pair work, and then none of them work. So no matter what X was, the number of accurate weighing options. So again, it's not did it work or not work. It's how many of them did work. So right here, my X would be 3, 1, 1, 1, 2, 2, 2, and 0. So let's possible outcomes that correspond to X would be, well, X would be 0, which none of them work. 1, only 1 works. 2 won't work, and all 3 work. That's the answer for A. B, which X value corresponds to having 1 accurate scale? So for B1, it's saying, hey, which one of these corresponds to having 1 accurate scale? Well, it's pretty simple. 1. Right? 1 says you have 1 accurate scale. It doesn't say which one, just you have 1 in general. 2 represent you have 2 accurate scales, like down here. B2, at least 1 accurate scale. So at least 1 means, I always try to think like cookie size. If I want at least 1 cookie, that means 1's the lowest, so it's X is greater than or equal to 1, right? 1's the lowest, 1 or more is essentially what this means. So in terms of X, if they said at least 1, that means 1, 2, or 3. 1's the lowest value, and then you can go higher. And that's the first example. Let's do one more, make sure we got this. Suppose 3 coins are tossed simultaneously. Let X be the number of heads that result. So again, X isn't heads or tails, it's the number of heads that result. Say the possible values of X. Well, if we're throwing heads up if we're tossing 3 coins, I could get no coins. What they're all tails, so no coins of heads. I could get only 1 coin has a head, 2 coins have a head, and then 3 coins. Let's turn up heads. So those are the possible values: 0, 1, 2, 3. Okay, no heads, all heads, and all the mixture in between. B, list the possible outcomes and the corresponding values of X. So there's basically, how do you get each of these outcomes? Well, if I got no heads, that means I got all tails. If I got, this would be my B. If I got 1 head, that means that you only got 1 head and 2 tails, or tails and heads. All those combinations of getting 2 tails but 1 head. If I got 2, that means you get 2 heads. So head, head, tails, or tails, head, head, or head, tails, head, head. Right, so there's 3 different ways to get that, 3 different ways to get this. And then what if you get all heads? So head, head, head. And there we go.